For our next topic, we're going to move on to the next of our common relationships. It's yet again a many-to-many, but this time with a no payload, I should say. Sorry, I'm getting myself confused already. Okay, just going back to our PowerPoint slide. This is what we dealt with last time, right? Where we have an intersection table, supports a many-to-many. In this case, department and office is in a many-to-many, and that's supported with this one intersection table because we have the two foreign keys in here. Basically, it acts as a child in this family, right? And that was, pretty straightforward. We see this all the time. It has its own primary key, often an integer identity. It'll have its own controller and views for managing the employee, for example, the intersection entity itself, right? But another very common situation is when there's really nothing else to say except that the two parents are related, right? So a student is in a course. Actually, a student can be in many courses. Course has got many student. All you really need is to check off for the student, okay, what courses they're going to be enrolled in, right? So that's a simple relationship. There's nothing else to say except that, yes, there is a relationship between the two. So in this case, there's no payload. There's no other data stored in the intersection table. Just the fact that there is a record there associating or relating these two entities together, right? So which is why we see in my enrollment table here, this intersection table, there's nothing there except these four properties. We know it takes two properties to properly describe a foreign key using entity framework code first, right? So we have the parent object along with a integer to represent the parent's primary key, and usually using the parent class name with ID at the end, right? Simple dimple, that's all we have to do. But of course, without its own primary key, right? We have to go to the Fluent API and create a primary key based on the composite, the combination of those two integers, the student ID and course ID. Right? And it makes sense that a student can't be enrolled in the same course twice, right? And a course can't have the same student enrolled twice, and so on and so forth. Okay, so that's one thing we have to do extra. Also, we should mention that this is usually managed right from one of the parents, or maybe sometimes both, right? So you might go into student and check off what courses they're in, or go into course and check off what students are there, right? Things like that. But we don't usually create a separate controller just for the enrollment itself. That would be kind of silly. All right, so it's a bit more to do though in the DB context. We do need, as well as the two parents, we have to add a DB set for the intersection table itself. And because there's no primary key that the naming conventions can handle, we have to use that on model creating and the Fluent API to come in and say, hey, guess what? This table has a key made up of the two fields, student ID and course ID, as we do in this example here, right? And as I mentioned before, checkboxes are very common. Also, sometimes though, you get too many checkboxes to easily show on the screen. So you might resort to having a couple of list boxes, multi-select list boxes where you can, that familiar thing of move options left and right back between the checkboxes and so on, right? But this is all for situations with no payload. And of course, we have to think about cascade delete as well. And usually we find in a situation like this, one of the relationships you would want cascade delete. For example, if you're going to remove a student, it makes sense to remove all the enrollment records for that student, whereas you would want to be prevented from deleting a course if there are any students enrolled in it. So in our case, we're going to do sort of the medical history of a patient. So we would want to delete that if we're actually removing the patient, right? Because there's no point having a history of them if we don't longer have them in the system. Whereas we would want to prevent deleting some of the options for medical history, some of the different conditions patients might have, measles, mumps, and so on, if there's any patients that have had that in their history, right? So that's the last thing we kind of have to worry about. So let's get back to our example. So what I've done is I have Visual Studio open where we last left off, right, after adding our other many-to-many relationships to the appointment and the appointment reasons, right? So using my copy-paste file as a guide, what we want to do is we're going to go into the medical history, right? Let me just bring up Blackboard again here for a second. So as I note up here, right, we're going to look what medical conditions have you had in the past? Think of this example. You go to a doctor's office, you're coming for the first time. They give you a form and on a clipboard, you sit down, and you put some information at the top and you start checking check boxes. Have you ever had mumps or measles or whatever, right? In your medical history. And you check all these things off, fill out a few other things and sign it and away you go. So that's the example I'm going to use here. Now it's a little simplified, I know, but it'll do the trick for getting this programming concept across, right? So we'll start by adding the actual models needed themselves, right? So coming over here, I'll add a view to the models folder. Okay, or sorry, a class. Did I say view? I meant class, right? So one for the condition itself. That's the phrase I'm using or the name I'm using for, this different like measles, mumps, the different medical conditions you might have had in your past. Okay. And I'm just going to go right away and put the code in place and we'll talk about it because you've seen me do this kind of thing a few times. I don't need to go prop tab and make you watch me do all that. So here's my primary key, integer ID. Okay. I have to add the using for my data annotations namespace. And then I have all my annotations here. Now, it's complaining about patient condition because that class doesn't exist yet. Just to even maybe mention that patient condition, when we have this many-to-many without a payload, right, sometimes there's not a suitable name to use for this intersection table. Now, that's kind of not the case in your homework assignment where you added applicants for job postings, and then, the logical name would be an application, right, for many-to-many between applicant and a job posting. Here, we don't really have anything that I can think of very well. So the other common naming convention we'll do, there's nothing magic about it. It's just something we'll often do is we'll take the names of the two parent classes involved in the many-to-many relationship. So patient and condition. So I'll just call the intersection patient condition, right? So I might as well add that class next. So I'll add another class here for patient condition. Okay, now this one, as we mentioned before, the only thing that goes in here are 4 properties. Count them, just 4, right? The two parent objects, the condition and the patient, and of course, something to relate to their primary keys. So following our naming convention for foreign keys, the parent class name with ID at the end, and the same data type, and away we go. Now, I'm not going to bother with any annotations in here because remember, this never really gets a visual presence on the screen using our scaffolded controllers and views, right? We're going to manage it always from, most often we'll just use the patient, right? Go into the patient information, check off what conditions they've had in their medical history, right? Okay, so that's good so far, but we need to do something else. I need to add into the patient, right? So I'm going to come over here, I'm going to copy and paste because this is exactly what I need to add to the other parent in the family, right? This collection of the patient conditions. So let me come down here to patient. I usually stick these near the bottom. Okay, because patient condition doesn't make a very good label or caption, I'm going to give this a display name. You probably noticed that even in the condition class. History, medical history, something like that. I want to keep it short if I can for a column heading. Okay, now of course we do have our constructor. So good practice. We're also going to put in here the code to create our empty hash set, right? It's important because later on in code, when we start creating these objects, all right, and constructing them, if we don't do this, we always have to initialize these collections before we can actually work with them. So this avoids those null reference exceptions by having this in here. All right, that's it. Those are our 3 classes. So just quickly to review, we added this as well as the collection itself, right, to the one parent. The other parent in the many-to-many is our condition, okay, our medical condition they have in their history, right? And of course, both the parents have the collection of the common child here, and that child is made up of nothing but the 2 foreign keys. Now, we do know, we talked about this, we have to come to our context, okay, our medical office context, and we need to add, well, in my case here, 2, right, because conditions is brand new as well. So a DB set for both of the new entities or new classes that we just added, right? So there's condition and patient condition, right? Pluralize, okay, remember I've seen a few students work where they keep forgetting to pluralize the DB sets, and it's a very good practice because it makes your code much clearer and easier to read. Now, the next thing we said we have to do down here in on model creating, right? There is no primary key defined for our patient conditions entity, right? So that will do, okay, we'll create a primary key for that using the Fluent API. We'll just say that the entity patient condition has key, right? It's this new class, a combination of condition ID and patient ID, right? And that's it. That creates the primary key for us. And the last thing is we also want to prevent, as we just discussed, you shouldn't be able to delete a condition like measles if you have any patients that have had that condition and they've recorded that into the system, right? So similar to what we did here with the doctor and patient, right? We'll just restrict that one side of the many-to-many relationship. Now, deleting a patient, it makes sense. You would want to automatically delete all the related patient condition records, right? Because the patient's gone. So who cares about the history? We don't have the patient anymore. So that's it. Those are all the changes we need in the context. So we really should probably do a migration next, right? Now we're using SQLite, so you know what we have to do. I'll come in, I'll delete the database, press the delete key, there it is gone. I'll delete the entire migrations folder because we only deal with one at a time with SQLite. And that's it. So I'm going to use my common commands here. This command will take the new arrangement and create the migrations folder, creating the one migration that's going to do the trick for us. I probably should have done a build because when you use the package manager console this way, you might be told there's a build error, but you won't be told what it is, right? But I'm going to cross my fingers and hope that I don't get any build errors. And good. Okay, build succeeded. So there's my usual warnings there about schema and so on, but everything else went through fine. So we have my one, okay, migration here that creates everything, all of our tables, the intersection tables, everything else, right? With all of the way that we want it done. Good. Okay, so I could update database, but you know what? Remember once more, program CS, when it hits this line here, it's going to actually call update database for me. And then it'll want to seed my data. Ooh, that's a thought. Let's seed some data as well. So I'm just going to close all the tabs at the moment. And let's come back to our medical office seed data, right? So we know certain things, right? The order matters here. So I have to have patients before I could create the intersection table, but I also have to have conditions, right? So as long as it comes after the required objects, it doesn't matter where, but I'm going to put it right under here. Now this is just using the old add range approach, right? So maybe just throw it right in here. And there's some conditions, okay? So cancer, heart attack, diabetes, I should have had measles and mumps, but you can do that yourself, okay? Now, there's nothing else coming after, so I have the two things I have to have. I have to have patients, I have to have conditions. So I can go on now and add some patient conditions as well. So this code is written, again, in the old approach of just using link queries to go and get the objects as required, right? But it'll do. It'll do to get me a couple quick. Okay, if I had more time, I would rewrite this using my nice for loops and so on to get more data. But okay, I do know I have these particular patients created. Okay, Fred and Wilma Flintstone, basically, and that should give me a few records to just start with. Okay, so that's it for my seed data, right? So that should work, I'm hoping. And before I would see that, though, I have to make a few changes to the user interface. So before I do a test run, let me come in here. And I'm going to make a couple quick changes. I'm going to go to the patient index, right? So views, patient index. Now, I don't want to clutter this up with too many columns. So I already have 5 here. I don't want to add any more. So I've decided that email really doesn't need to be here. I can always click on details for any patient to go and see the email address, right? So what I'm going to put here is patient conditions instead, right? And good thing I did a display name, because I can just come down here and go patient conditions, okay? Actually, the dot, the IntelliSense would have worked as well. All right, so now in the spot in this table cell where I want to show it, this isn't going to do the job for me. I actually have to have a loop, right? Because remember, there can be many conditions for the patient, okay? So I'm going to put my code in place and we'll talk about it. So it's a little bit of razor code. So I have the @ symbol for jumping into the C# of the razor code. I have a for each loop, okay? Bar C and item. Remember, each item as we go through here is one patient at a time. So as long as we have loaded the patient conditions into the patient record, okay, into this item, then we'll have data in here. So for each one, we'll go through all the conditions in their history, right? And then here's a neat trick, C.condition, right? But remember the condition object inside patient conditions, okay, will contain the condition name, right? But only if we've loaded the condition into the patient condition as well. So we have to make sure we get patient, we load patient conditions, and for each patient condition, we have to load the actual condition so we can get to the condition name. Whew. In other words, we've got to have the whole family in play, right? Both parents and the intersection as well. So how do we achieve that? How do we make sure this data is available? I'll tell you what, I'm going to run it without first, and you'll see the effect. So let me just get this up and going. So this should create the database, seed the data, right? Do all that and bring it up. And here we go. How come I don't see any data? Well, I'm pretty sure my seeding worked. And even though I have code in the view here to show the medical history, okay, it's not available, right? It's not appearing. Well, whenever you get a situation where I'm sure I should be showing something and you're not, odds are you didn't include enough in the link query. So let's just come back, right? So this is great. This code should work in theory as long as the patient knows about all the patient conditions and that each condition, patient condition has a fully materialized condition object inside of it as well. So to guarantee that, let's come up to controllers, into our patient's controller, and to the index. That's what the action we're working with. And I see the problem, right? We have patients.include. We're including the doctor, but we're not including anything about our new entities, right? So I can carry on, right? I can also go dot include. Include what? Well, B goes to B dot patient conditions. But that's not enough because the condition object inside there won't be populated, so it won't be able to grab the name of the condition. Well, how do we do that? Well, as I pointed out in my note there I put up today from our tutorial on working with complex objects, we can go then include, right? So you start off with the include, then you can go then include. Okay, what are we going to include this time? Well, by the way, I can just use P here as well, because really it's just a placeholder variable, and each is independent. Goes to P dot condition. Okay. So that's how it works. So I'll get my patient. By the way, I'm including the doctor as an object, so it'll do a join to the doctor table. I'm including the patient conditions, so there'll be a join there. And then it'll do a join as well across to the condition table. So that means that when I materialize my patient, each one will have information, all the fields of the doctor. I can go into this collection of conditions, and each one will also have that condition object fully materialized so that things like the condition name are available there. Whew, that's an awful lot of work being done for me just by going dot include and then include, right? So we're just kind of walking across the relationship. If you picture coming down from patient to patient conditions, then up the other side to condition. And that's it. So with that little change there, let me just run this again. And hopefully, I have a little drum roll coming to patients. And there we go. So now I'm seeing the history that was seeded in my seed data, right? Okay, well, that's great so far. But what about if I want to say, oh, Wilma, we forgot to check off she already had something else in her history, right? Well, then how can I do that? If I click edit, there's nowhere to change it yet. Okay, so that's our next step. I'm going to stop and start the recording.